Hi guys, welcome to my AI system design playlist. So we have been talking about backend, we have talked about front end as well, and we have talked about microservices versus monolithic as well. So today I'll be talking about choice of DB. So guys, as I said that there'll be two big choices which you need to make. One is microservices and another is monolithic. I think you understand that concept now. But another very important choice that you need to make is what would be the DB that you would use. And guys, this is very confusing as well. But oftentimes, like 80% of the times, it won't be very confusing. But maybe 20% of the time, it would be some sort of confusion that you will have. Because, see, guys, a lot of time, specifically in industry when you're working, you will find out two things which no system design person will tell you. One is what expertise your team has, and secondly what are the cost constraints. So these two things are also very important. So an example, let's say you understand that hey, maybe NoSQL database is better, but then you don't have costs available for that because usually it's expensive than SQL database. Or let's say the thing is no one in your team has expertise to deal with the NoSQL database. So all this would really boil down to an idea of choosing the right database. So I'll tell you guys use case by use case. So guys, usually let's say you want to build an ML app, okay, which will, let's say, at most have 100 to 500 concurrent requests, and whatever data you want to collect or you want to store in terms of retraining and everything, and mostly everything is guys in numerical format, okay. So it's more like if you have height, weight, stuff, just predict that whether I'll be having diabetes or not, whether the person is going to do a fraud or not, what would be my sales. So for these type of databases, guys, for these type of use cases, just close your eyes and go for relational SQL databases. So MySQL, PostgreSQL is there, SQL Server is there, whatever cloud provider you are using, even you can like connect with their executive and understand that hey, which is the cheapest tabular structure, or you can do your own research as well, because guys you won't be doing it in your PC, right? So anyhow you need to be in touch with your cloud vendor, just understand what SQL services they offer. Most of them are same. Just look at the way you want to store data and make sure that has a connector to your programming language that you are using. Just look at the pricing and get away with it, because guys, see, if you need tabular data, right, then SQL is the best, and SQL will be the best for long time. And moreover guys, SQL helps you just get started with data in a tabular format, and then because you would might collect some user feedback data in order to retrain your system. So if you're creating something on those lines, then relational SQL database is your go-to choice for any ML based application, okay. Now guys, let's say you've created a DL based application, and let's say you want to have an app where someone is uploading an image. So guys, tell me, will you use a SQL database to store image data? I don't think so, guys. That's quite obvious, right? You won't be storing an image data into SQL. So that for that purpose, or for any textual long text strings, NLP apps, you would be guys switching over to NoSQL. And also guys, for images also, NoSQL has some limitations, so we'll talk about that as well. But specifically for NLP based workloads, or workloads where you don't have a fixed schema, right? So the good part about NoSQL databases is that it provides you schema flexibility. You don't have a very fixed schema. It is completely like, let's say, a chatbot kind of an app. So for that reason, guys, you have to go by NoSQL database. And you have MongoDB, Cassandra, okay, Cosmos DB. So whichever database you find is good, you can use it. So I'll tell you a use case. So the use case was that basically some IoT device was there. Okay, let's say you have a sensor and that is ingesting data into some place, let's say MongoDB, and you need to run analytics or let's say any AI or ML stuff on that. So you could probably just connect directly to MongoDB as well via Python and get started on it. Or what you could do is you could write a script that would move your MongoDB stuff to SQL, and from SQL you can connect a Python. So guys, all these things are like done based on time constraint and what organization want, but there are multiple things. Now if you're creating a product, then obviously guys you would use a hybrid solution, that is for sure. Okay, let's say for logging details and all those things, you might want to use a simple SQL table, right? You just want to log what user came at what time. Maybe there's a users table, and for that you want to go for a SQL database. So first case is guys, in most applications that are deployed today, they use a blend of SQL and NoSQL. It's not that this is not a hard and fast rule that if you take SQL you can't take NoSQL. If you take NoSQL you can't take SQL. So it's very dynamic. Okay, some people do it like this way, that they separate the analytics data and non-analytics data as well, so that hey, whatever data on which we need to run a lot of analytics, let's say users, let's say the amount of payments made, let's say total revenue, let's say total purchases of this product, all these kind of things best are SQL for SQL use cases, right? You can write SQL queries in a efficient manner, right? So going for a hybrid solution is always the best case, that is for sure, and most organizations go for hybrid solution. Every app you would see leverages both of these. Specifically same goes for AI apps as well. Okay, they would also have SQL, they would also have NoSQL database for sure. Now just keep in mind guys, sometimes what happens is that people usually on like day one just don't throw up a NoSQL database because of two things. One is they are cost constraint, and another is lack of expertise. So sometimes they say that hey, we are not sure that how much of an app is going to work, we would stick to a relational database as of now. If we see that hey, we are getting traction, then maybe in order to scale the system well, we'll do it. But I mean guys, these are calls that you would take. But now you understand that hey, whenever you want to store some textual information, long text string, chat histories, NLP based workloads, let's say you want to encode your image into 64-bit and store it, everything happens in a NoSQL database where data is in the format of JSON, right? So name, let's say name is Aditya, okay, age is 29, something like this in a bracket format. Everything gets ingested and everything is usable. Also guys, for like MongoDB and all, there is programming language called MQL, so where you could query MongoDB via that as well. So every DB would have its own system where you could query. So just relax and just probably start with a hybrid solution, and as and more it's possible, just go for SQL database. As and when you know that hey, SQL is not going to work, go for NoSQL database. So that's pretty much done. Now comes the graph DB. So guys, graph DB usage is little limited because most of the times we are not making social networking sites, most of the times we are not making recommendation systems, and for fraud detection it's optional. It's not necessarily that for fraud detection you need to have a graph DB. But guys, for social networks, what happens is that let's say I am your follower, then you are followed by these three people, these three people follow, let's say, this celebrity, and this celebrity follows this, and something. So by default only this use case is like a graph. Okay, so usually your process of system management becomes very efficient. Okay, specifically to social media management, if you're creating a social media app, then you would need people who understand graph DB like Neo4j very well. So I hope on day one you're not creating a social media website. So that's the case. And guys, for recommendation system, yes, you can use graph DB as well, but you can skip that as well, because even I had built a recommendation system in my YouTube channel. So even I didn't use any graph DB and it was probably working fine. It just depends upon the complexity of recommendation system that you are designing. Again, recommendation system by graph DB can also yield great results or not yield great results. It's just about the use case that you're trying to solve. Okay, for fraud detection it's okay, you can skip it for the time being. So then there's like column this columnar database. Okay, this is also lately becoming very popular, specifically for one use case, that is high write speed. So what happens is you need to write data into DB multiple times, right? Let's say if that kind of a thing is there guys, you need to go for, might be going for a columnar database along with a NoSQL database and along with the SQL database. See guys, now you can even like have three databases connected. So as I said guys, always we'll have a hybrid solution. It's not that we would just go for one DB and set, it would be a hybrid solution. So just understand guys, usually this is Cassandra is extensively used for high write speed, and let's say some application is connected, website some people have made and that's connected, a lot of data is coming, so you can directly connect with Python, and then you need to learn, okay, what Cassandra is, how we can analyze the data, how we can move it into a simple file. All that work is usually done by data engineer, but sometimes data scientists or data analyst also needs to do it. So just try to think in that term as well. Now comes the most popular most popular system, that is vector DB. Okay, vector DB is very popular lately, okay, because of NLP and chat GPT 2022. So guys, vector DB is more like, in order if you wish to store vectors, so let's say you have a text string and you have a text string, I love you. So your vector would be something like this. Okay, let me just increase it. Okay, so let's say you have this, I love you, and then you would probably have, let's say, vector like this and this, and the dimension of it can vary, it can be 256, 512 and stuff. So that's depending upon the embedding model you're using, but you understand, right? Words are converted into, let's say, numbers, and these numbers have semantic meaning. So let's say love and like, if would be there, and if you would compute any measure of similarity, let's say cosine similarity, they would turn out to be more similar. So now you can guys directly like embed, like let's say you want to build an app wherein you're doing a PDF search, right? You want to create an application where users can come and upload their PDF, and then stuff will happen. So for that, obviously you need a vector database. There is no better option for it. Okay, again guys, try to understand that vector DBs are great, but even I'll give you an example. So let's say you have done NoSQL database. Okay, then you can read your data, convert it into vectors using some vectors embedding model, and maybe run another pipeline to push vectors over here if you wish to later analyze them or do any kind of fine tuning. So you are able to see how you must be having a SQL table, SQL, NoSQL, analysis, and a vector DB as well. So guys, you may end up using all three, but as I said guys, most of the times you'd be going for a hybrid solution. Lately this is very popular since a lot of RAG based applications are happening across organizations, across industries, and for that you need a vector DB because that's where your stuff happens. So it's good guys, you can use a vector DB as well, but just try to be remembering that it's a little different, and it's best when you have to do vector search, which is very important, right? So search part is very important. It's not like a SQL like database. And another thing is it's little costly as well, but I think a good part is that lately the competition is rising. So whenever a lot of competition rise, so there are one good thing as well that happens for enterprises is there is a pricing war that happens, and it might become good for people as well. So over time you would have seen, right, that the prices of models have gone down like by 100x as well. And in a similar manner you will find out that vector DBs also would slowly lower their cost, and they would be extensively used a lot guys in future. So you need to understand vector DBs. Obviously if you want, you can go to my NLP playlist or generative AI playlist. I think in my generative AI playlist I would have covered vector DBs as well. Would have covered RAG as well, so you can just read about it. And guys, please subscribe to my YouTube channel, and slowly a lot of content will come over here which is industry standard, and I'll make sure all of you become AI experts. Thank you and have a great day.